Okay, so we left off saying that we went ahead and graphed the vertex and the focus and decided that because the focus was above the vertex, that this parabola would have to be opening upward for the fact that the parabola always hugs that focus. So I know the equation that I'm dealing with is positive, not negative. If it was negative, it would be going downward. 4p, and we said y minus k is equal to x minus h squared. So in order to finish this, we need to sub in the p value, the k value, and the h value. So the p value we need to determine, and we would just count what the space between the vertex to the focus is. And if you went ahead and saw that this vertex is at 2, 1, and this focus is at 2, 4, I went up 3 units. So P is 3. And if you could always count it, I just look at the Y values, take the difference. So P is 3, and my vertex, again, is H, K. So now I have all the information necessary to write the equation. P was 3, then it's going to be Y minus 1 is equal to x minus 2 squared. And last but not least, you would clean it up and get 12y minus 1 is equal to x minus 2 squared. Okay, if you decide to write this side of the equation first, that's fine. Either way, this would be the answer. All right, let's try the next problem. It says find the focus of the parabola. So now I look at this and there's a lot that I don't like. First of all, for me to find the focus of the parabola, I need to get it in some sort of vertex form. So we want to try to get it in the fashion, again, we see that it's negative right there, and we see it's x squared. So I know that I want to get it in the form of negative 4p y minus k is equal to x minus h squared. So I need to figure out the vertex. So we know how to put this in vertex form from last year, and hopefully you remember we have to use complete the square to do that. That's why we went over it the other day in class for solving quadratics, and we probably, I know Ms. Vavrika probably also, as well as I, mentioned that we will be completing the square a lot in this unit to get the equations in the correct conic form. All right, so number one, I do not want to deal with fractions. So what I'm going to do here is I'm going to multiply every term by 2. If I multiply everything by 2, these 2 in the denominator should cancel. So I get 2y is equal to negative, I multiplied 1/2 by 2 and I get negative 1x squared minus 2x plus 1. And then I need my leading coefficient, but for me to complete the square, to be positive 1. Right now it's negative 1. So I'm just going to go ahead and divide everything here by negative 1. So if I divide everything by negative 1, I should now be in the right form. So I got negative 2y is equal to positive x squared minus 2x plus 2x, and then it's going to be a minus 1. Okay, so now I'm here. All right, for now, in order to complete the square, I need to set the equation equal to c. Basically move my constant right here over. So I'm going to add 1 over. So here I'm adding 1, that gets crossed out, and add 1 here, and I'm left with negative 2y plus 1 is equal to x squared plus 2x. All right, now I'm trying to think of what do I add in this spot. You have to take your b value, which is 2, so you're going to take 2, b divided by 2, and then you're going to square it. And remember, I always like to show this step, that's 1 squared, and I'm adding 1 to both sides. And there was no GCF here that I had to worry about, so it's just going to be a plus 1 here, and then yet another plus 1 here. So then on this side, I'm left with negative 2y plus 2 is equal to x squared plus 2x plus 1. Now I have a perfect square trinomial, so I can factor this to x plus 1 squared. So I've got this part done, so I'm happy with that. And now I got to get this side to somehow look like this, right? So I want the coefficient on my y to be 1. So on this side, I'm going to GCF a negative 2 out. I want that to be 1. So if I GCF that out, I'm going to get a negative 2, and you're going to get y. Be careful, you're dividing by negative 2, so minus 1 is equal to x plus 1 squared. So we're almost there. Now we just want to pull out the information. So the equation is now negative 2 y minus 1 is equal to x plus 1 squared. And I want to label my vertex. So your vertex is always h comma k, okay? The h is always with the x, but it comes out opposite. I always say when you pull something out of a parentheses, it's going to be opposite. So I'm not going to say h is positive 1, it's negative 1. And then k, it's the opposite, it's always with the y, and that's going to be positive 1. So that is my vertex. Now for me to find p. If I wanted to find, I need to find p in order to find the focus. So right now, if I needed to sketch this graph, I know it's negative 1, 1 is my vertex. I know it's opening downward from the beginning equation that the leading coefficient was negative. So I know my focus needs to lie somewhere over here. So let's see where that is. We have to figure out what p is. Well, p is represented by the first number. So you're looking here, the negative just tells me it opens downward. So that is right there, it opens downward. 4p is represented by 2. So I'm just going to say, well, 4p in my equation is equal to 2. So I want to solve for p, and I get that p is equal to 1/2. So p is the units that I need to go away from the vertex up to get to the directrix in this case, and down to get to the focus. So if I know my vertex here was negative 1 comma 1, and I'm going down 1/2, right? Well, that's going to tell me that the focus is going to be somewhere there. Well, the x value will be the same. It's still going to be negative 1. Down 1/2 from 1 is going to be 1/2, and that is my focus. So we were able to find the focus to be negative 1, 1/2. All right, next one is find the standard form of the parabola with the vertex at the origin and the focus at 2, 0. So again, I'm not even knowing, I know it's going to be one of my formulas, but I'm not sure if x is squared right now or y is squared, so I'm going to give this equation a sketch. Well, the information a sketch. They're telling me the vertex is at the origin. So right here, I plot the origin. They tell me the focus is at 2, 0. So if this is my focus and this is my vertex, I've already said the parabola will always hug the focus. So that's going to tell me that this is going to open to the right, sideways. So as soon as I see that, I go, okay, my y minus k is squared. My y is squared, not my x. So in this problem, if it opens to the right, the leading coefficient's positive. And now you're going to say it's 4p, but 4p now is with the x minus h is equal to, so whatever, 4p is always with the variable that's not squared. And then you got y minus k is squared, where hk is still my vertex. So my vertex, that he said, was the origin. So I can right away go, okay, well, 4, I got to figure out what p is. X I like the origin. You're just plugging in 0 for the vertex. And then the p-value, we said, and we should feel comfortable with that now, is that it's the distance between the vertex and the focus. Well, how many units to the right did it go? It just went 2 units. So my p-value is 2. So cleaning it all up, I get 8x is equal to y squared. And that's my equation. Okay, on to the last problem. You've been a sport, I'm sure, listening to the very, very long lesson. Find the vertex, the focus, and the directrix of the parabola. Sketch its graph. So I look at this and I go, oh boy, I need to get it in the correct form. I see x is squared. I see the leading coefficients positive. So I know I'm looking for my equation to look like this. 4p y minus k is equal to x minus h squared. Okay, so what do I need to do? I need to force this problem, this form. So I'm going to keep x squared plus 4x on this side. I'm going to now minus the 6y over and add the 2 over so that it cancels on that side. And now I'm ready to complete the square so that I get the perfect square trinomial, so I can finally factor it to identical factors. So when I complete the square, my b value is 4. I take 4 divided by 2. I get 2, and then I need to square it, and I get 4. I need to add 4 to both sides. Always conscious that I didn't take out a GCF, so I add 4 here, and I add 4 here. So now this is a perfect square trinomial that factors to be x plus 2 squared is equal to negative 6y plus 6. Now, what did I tell you my leading coefficient on y had to be? Has to be 1. So here, I need to divide out the 6 to get that coefficient to be 1. And then I'm left with y minus 1. Be careful of that sign. And x plus 2 squared. All right, excellent. Now, this is my equation in the correct form, and I'm ready to pull out all the information. So, the information that they wanted from me, they wanted my vertex, so let's start with that. Here, the x value is with the x and the y value is with the y. For the vertex, you just take out the opposites. So my vertex is going to be negative 2 from here and positive 1. And then I'm going to just also give it a sketch as I'm trying to graph it. So when I do that, it's negative 2, comma, 1. I know this is a parabola that's opening upward because the leading coefficient is positive. So I know my focus is going to be p units up. So my p-value is represented here. You need to take 4p and set it equal to 6. Divide by 4, divide by 4. I get p is equal to 3/2, which is 1.5, correct? So that's the same thing as 1.5. So if I want to find my focus, I'm going to keep negative 2 the same of my vertex, right? Because I'm staying at there, and I'm going up 1.5. So my focus going up 1.5, I'm going to land here, and that point is going to be negative 2, x doesn't change, and if I add 1.5, I'm going to get 2.5. Okay, so you can tell me the focus is negative 2, comma, 2.5, or you can write it as negative 2, comma, 5/2, which is another form of 2.5. Okay, lastly, they said the directrix. Well, the directrix, you're going down p units, correct? So if I'm at 1 and I need to go down 1.5, then my directrix is going to be this horizontal line, and it's going to be, and I'm just going to write it here before I get cut off, the directrix is y is equal to negative 0.5, or 1/2, negative 1/2. All right, so definitely review this if you need help, and the homework is posted that you should be doing off the worksheet. Have a good day.